Hey, hello, this is Xiaohua, and today I'm going to have a presentation of CX 6 to 20 final project. My teammate is Hao Zhao, Jiang Yiling, and me, and we're working together on a topic called Titanic disaster. So let's get started. So our target is to predict the survival on the Titanic. I separate the presentation in four sections. The first is defining the problem statement. Second, called data analysis. Third is feature engineering, and the fourth is modeling. So let's start with defining the problem statement. We are supposed to complete the analysis of what sort of people were likely to survive. In particularly, we are going to use the tools of machine learning to predict which passengers is going to survive in the Titanic tragedy. Uh, we separate the task to three people, and I'm using the decision trees and the SVMs to predict uh, to to do the prediction. Uh, these two models are not intended to be the most accurate Titanic survival model, but during the project, I learned how to create, visualize, and the classification. These kind of things, which is definitely beneficial in my understanding of the data mining and machine learning models. So let's talk about the data analysis. In the graph, you can see that this is a graph about survival and death, and the three different color means the people in belong to three different classes. The first class people are more likely to survive in the disasters, and the third class people are more likely to dead, according to the graph, according to what's shown in the graph. And we also have one column in the data which is called sibling and spouse. So we can also conclude that a person aborted with non-sibling or spouse are more likely to die, and a person abroad with more than two siblings and spouse are more likely to survive in the chart. So this is third chart, which shows that if a person brought it by himself, he is more likely to die because he doesn't get help from any other people. And if a person brought it with more than two parents or children, they are more likely to survive. Maybe they help each other, they get a better chance of survive. So third, we come to the feature engineering. In this part, we try to drop the column we don't want, try to fill in the empty data, and then make the raw data more organized. Then we can train our model and predict the result. So in the feature engineering, we map the male and the female, which belong to the sex, to the numerical number. So male is mapped to 0 and female is mapped to 1. And there's also some data missing in the age columns. So we fill in the age columns data with the title's median age, which means like if he is a his title is Mrs. Then we're going to fill that one with the median age of the Mrs. people. So there's a lot of different kind of title. In the title we have Mr., Mrs., Miss, Master, Doctor, etc. So we map them. We concatenate them and try to map them into four numerical number, which Mr. equals to Mr. corresponding to 0, Mrs. corresponding to 1, Miss corresponding to 2, and other corresponding to 3. And there's also some missing value in the fear column, so we also fill in this missing fear with the median fear for each P class. So if this P class, if this person belong to class 1, then we will fill its fear with the missing value of class 1. We will fill the missing value by calculating the median number of that P class. And we also fill family size by sum the sibling spouse number plus the parent children number plus 1 to calculate the family size number. So we do a lot of like feature engineering to make our data more organized, then we can like train our model. The fourth part is called modeling. In this part, I use both the decision trees and SVM to predict the data. So for the decision tree, the target is that we try to find the best split for each node of tree. So we are going to use the method called Gini impurity to calculate. Gini impurity, which measures the disorder of set of elements. We, after calculating the Gini impurity, we find that the title feature is slightly better at reducing Gini impurity than sex. Then we are going to use the title as the first split. So you can see the get Gini impurity method here. We fill in the survival count and the total count. We try to count the Gini impurity of the sex and title. We compare with them, and finally we come to the result that title is the best choice for the first split. And during the decision tree, we also use a cross-validation to determine the best depths for the trees. We try to find the best value for the max depths of the decision tree by iterating through all the possible depths and measure the accuracy through the method called cross-validation. So you can see we iterate through like 1 to 10, and we get all the average accuracy of this tree depths. Then we finally figure out that max depth equals 3, the best option. So we are going to pick the max depth as 3 for our decision tree. Yeah, so here finally we see our decision tree is here. So the first line of each node is showing the splitting condition, which is in the form like feature smaller than or equals to value. Then in the next line, we find the Gini impurity of each node. The third line is the sample, which is simply the number of the observations contained in the node, like how many people or how many samples belong to this node. And then the fourth is called value. So the left side of value is the count of the not survived person, the count of dead person, and the right side of the value is the count of survived person. And finally, the class corresponds to if this belongs to a dead class, a not survived class, or this belongs to a survived class. So we use a model to predict data, and it's achieved the accuracy of 82.38%, which is pretty good. So the second, we use SVM to train our models. SVM to predict our result. So this is a brief introduction of the SVM method. So in the SVM method, we have something called a decision plan, which can separate between a set of objects have different class members, different class membership. So let's take Titanic disaster, for example. The object belong to the survival and the dead. So we need a decision plan to separate the death class from the survival class. When we create this, when we try to create this decision plan, we need to make sure that this plan will make the distance between the support vectors and the lines to be as large as possible. So next time, when we figure it like that, next time when a class comes, we can easily judge if it belongs to the death part or it belongs to the survival part. So here is the pros and cons for the SVM model. The SVM model works really well with clear margin of the separation. It's very effective in high demand spaces, and it's also very effective in case where number of dimension is greater than the number of samples. But since the it's a little bit like time consuming, the method, it doesn't perform really well when we have large data set. It will cost a lot of time, and if the noise in the data is very huge, it's also not a very good. It also doesn't perform really good because the target class will going to be overlap. So we use the SVM model to predict the data, and finally we got a accuracy score which is around 81% 60 which is 81.69%, so which is also pretty good score. So that's basically the presentation by me, and really helped Jiang Yiling and Hao Zhao. They gave me a lot of help during the teamwork, and hope you enjoy the presentation. Thank you very much. Have a good one. Bye.